All right, today we're going to talk about phase plots. This is a Bode plot, and the red curve here is a phase plot, and it looks very strange. So I want to talk about phase. I want to talk about phase plots because a lot of people get really confused about that weird shape. Okay, so we're going to be taking a look at a particular circuit here. It doesn't really matter what the circuit is. I'm just going to grab one of these. If you haven't seen this board before, it's available over on PCBWay. It's just a bunch of transistors and stuff. So I'm just going to use this one here. It's a cascode amplifier. So we're going to input and output through this cascode amplifier. We'll measure the gain and the phase through this. It has quite a big gain, and we'll look at the phase through that system. So that's what I have hooked up there. Let's go ahead and talk about phase first, okay? So let me make this part of the display bigger. All right. And let's see here. Let's go ahead and run this thing. And you can see here that things are pretty well in phase right now, right? That the valley, the troughs and the valleys, the mountains and the valleys, they're all kind of lined up. And as we change the frequency through the system, this is input and output, and they're going to start to separate. There's going to be a phase shift when you go through the system, right? Can you change that? No, I don't think you can change it while it's running this particular. Oh, you can. It's just really, really slow. Yeah, there we go. So you can, let's see here. Let's, all right, I'm going to invert one of the channels here so that the amplifier itself has a phase change, right? It's going to be 180 degrees. I'm going to invert one of them so we can see that at this particular frequency, things are about the same phase, right? That the peaks and the troughs are in about the same spot. Now if we go to the generator here, and I'm going to change the frequency, all right, where it's 600 kilohertz. As I go up in frequency, we'll get to a point where we can kind of see it now. You can see that the yellow is kind of shifted this way a little bit, all right? And let's see here, let's go up in frequency a little more. And we will look at here. Now it's slid over further. If we go down in frequency, it will get different. I just touched something. Oops. Generator frequency. All right, let's go back down. And we'll go slower and slower and slower and slower. I've got some averaging on, that's why it's doing weird things. And you can see down at these frequencies here, we're spot on in phase. So again, as you go through the system, the phase changes, all right? So let's go back and let's measure that with our fancy tool, all right? So I'm going to go to apps, and there is an FRA, frequency response, which is the Bode plot, and it will come up in its normal configuration, which I don't like. So I'm going to put this over on this edge over here. I'll make this small. There we go. We can watch it go up here. 100 hertz to stop at, let's say, 10 megahertz. 10 megahertz. All right, so let's go ahead and run this one. So hopefully you can see this again. All right, so right now, they're going to be about 180 degrees out of phase because it's an inverting amplifier. And then we're going to step along in frequencies. And I think now that you've seen the other demonstration, you can see that this one's going to be shifting a little bit in its phase relationship between the two. Here you can see we're getting closer and closer to getting in phase, which is actually 180 degrees, right? And And we can see that on the scale here. We started up here and we're down about halfway, which is about 0 to 180. So we're about 180 degrees out of phase now. We can kind of see that here. And then as we continue our merry way, it will start changing again. And there we go. This is the gain. The gain falls off because it's capacitively coupled in. You need to get a certain frequency before you start getting into the device. And then the amplifier itself starts rolling off past 1 megahertz, right? And here you can see, wait a minute, the phase graph looks pretty this time. It doesn't have that weird straight line in it. What's going on? Everything looks fine here. All right, so this is a function of the way it's being graphed. Currently, it started at a positive 155 degrees of phase, and it went down to a minus 100 degree of phase, okay? Had it started in the middle, it would have gone down until it ran out of space, all right? And it would have gone down here, and it's got to go somewhere. There's no place for it to go, so it starts up at the top again and then continues on its merry way. So sometimes you'll see that big break in the center that is not anything funny going on. It's still nice and smooth. It's just that particular graph couldn't fit it on all at the same time, all right? All right, let me try to explain this discontinuity one more way to help clarify things. So here's a screenshot, and you can see here the red trace is, you read the numbers over here. So it started at around 0 degrees, and it went down here to minus 180 or something, and then it came back up on the top again. All right, so what I'm going to do, okay, I've printed out 2 of these, all right, and what I'm going to do is I am going to use my scissors. And I'm going to cut one of these down, all right, and then I'm going to place it. I'm going to place it right there, okay? All right. So now you can see, if you ignore these 2 things, here's our real graph. It starts here, and it follows along, and there's no discontinuity. It just continues on its merry way. It's just that we didn't have enough y distance in order for it to plot correctly. So if you could just take this thing and shift it up, that's what it did on this other one that I did here, is it started high and then it came down and it fit on the screen. And this one here didn't fit on the screen, right? And so let's see here. Sorry, bumped the camera. So this line isn't really anything. It doesn't really exist. It's just putting a line between 2 plots. So that really shouldn't be there, right? You should just get this one continuous motion through this system. So we no longer need this one. We can black it out, and we no longer need this one up here. We can black it out. So this is our resulting phase curve, right? So anyway, if you see a phase curve with a big discontinuity in it, it's just a plotting problem. It has nothing to do with the measurement. It's not a discontinuity. It's perfectly smooth. Don't worry about it.